Hi guys, welcome back to the next video in our sort of video series, if you like, tutorials, talks, basically learning together, the Raspberry Pi. And today we're going to look at potentiometers, how we read the voltage of a potentiometer. Right, let me just show you a potentiometer. Here's one. Right, hopefully you can see that. Actually, this camera, for a change, is focusing okay. I've got two new cameras coming tomorrow with autofocus, so hopefully things will get better. Yeah, potentiometer, got 3 pins and a turny knobby thing on the top. All right. If we look at the board, we've got 3 here on our project board. 3 here. Right, now these potentiometers are analog, and we need a converter to convert analog to digital, so analog to binary, noughts and ones, and it's called an ADC converter. And on the board, if you can see it there, you can just see it. That's our ADC converter. It's 8 bits, right? It's 8 bits, and it's connected to our board. If you've got the Sunpowder kit or another kit, there is one in the kit that you will use, and you put it into your breadboard. Right, so let me get to the correct view. There we go. Now, there's a couple of things we've got to do before we can get going. We have to install some tools, etc. So let me just clear this, and we need to install the I2C tools. So it's sudo apt -get, yeah, install I2C, I believe it's dash tools, yeah. All right, now mine's already installed, but yours take a little while. But as you can see, I've already got the newest version. Yeah. Now we need to activate the interface, the I2C interface. So any of you remember this? Sudo raspi-config, yeah, got that one. Enter. Brings us this. We've all seen this before in a previous video. We come down to number 3 using our up and down arrows. Our mouse don't work on this, and then press enter. Now, if we come down using our arrows to I2C, enable to disable, okay, of the I2C kernel module, press enter. Would you like to arm the I2C interface? Click enter for yes. It's been enabled, and we click OK. Then we come down to finish and click finish. Okay. Now the next thing we need to do is, now normally it's on 48, but we need to check where our I2C detect is located, because we need this number for our configuration. So it's I2C detect, yeah, -y space 1. Okay, and there you go. As I said, it's 48. Right, it's 48. Okay with that? So we need that for our configuration. We need that number. Remember, 48. Normally on most, yours might be different, but normally it is on 48. All right, on most Raspberry Pis. Now what we need to do, we have to install what we call the SM bus. Now hopefully everybody's using Python 3, the latest version. So that's what we're going to do. Sudo apt -get, right, install Python 3 dash, I think it's dash, yeah, SM bus. Mine's already installed, but it'll go through and it'll install the SM bus. All right. Any problems, let me know in the comments. Yeah. So let's go to our code. Bear with me. We can close this down. Just want to make sure you guys can see what I'm doing. Yep. And let's open Thony. Now what I've had to do, I've had to put it this dark background because previous videos, because it's when it's white, it really brightens my face and it doesn't look that good. Hopefully when I know I keep mentioning these new cameras, we'll be able to sort that out. It's got better software to control the camera with it. So here we go. File, open, template, okay, that, remember that. Here's our template, file, save as. What are we going to name this? I'm going to just name it adc.py, yeah? adc.py. Don't forget the extension .py. All right, and we'll okay that. So for the first time, I think, because we're not using any GPIO pins, we can take this out. Right, we do need time, and from our tools, right, from our ADC tools, we go from ADC device, import star. Star means it's a wild card, basically, everything. Okay, so then we go to ADC. This is going to this line defines the class, yeah. ADC equals ADC device import, brackets 0 times 48, brackets off. Right, as I said, this defines the class, right, the ADC device class. Right, that's the only attributes we need for this program. Let's come down to our setup. We need the global, but this time we need global ADC. Right, we need global ADC. We do not need GPIO pins. So we get rid of that. Excuse me. Okay, so if, right, brackets on, ADC dot detect I2C, capital I, sorry, that's a 1. Where's me I2C, yeah, brackets on, 0 times 48. Oh, dearie me. It's brackets. Yep, times 48. Remember 48 was the magic number, yeah, when we looked, and it's 2 brackets off, brackets to close the 048 and brackets to close the ADC, colons, automatic indent, yeah, ADC equals AD and it's S7830. Yeah, 0 times 48 brackets off. Okay, ADS 7830 is our converter. Cool. So enter backspace to under if. Now we go else. Yeah, colons, enter. Now this command, I'm going to read it very slowly. I didn't want to, the reason I've copied and pasted it is because I don't want to mess up the configuration. So we'll go through it. Else, print, exclamations. Is it exclamations? What are they called? When they go like that, I forget my mind. But anyway, you can use single quotations or double quotes. No correct I2C address found, comma, forward slash, not backslash, N, what? I keep forgetting. Then again, please use command I2C detect -Y1. What's it called? I forget. Oh, my mind. To check the I2C address, that's the exclamation mark, /N, quotes, program exit dot /N quotes bracket semicolon. Yeah, just check I've got that right. Yeah, and enter, exit, commas on, minus brackets off. Sorry, brackets on, minus brackets off. Sorry, -1 brackets off. Right? Yeah. Look at that command, write it down. Yeah, it's quotes, isn't it? Quotes. All right. My mind's going, I'm telling you. Let's go to our while loop, shall we? So, while true is always true, exclamation mark, enter, gives us our automatic indent, yeah? So it's a value equals ADC dot analog read, yeah? Analog read, brackets on, 2 brackets off. Read the ADC value of channel 2. Right? That's what that command means. Voltage equals value / 255. Remember, that's our maximum for an 8-bit number. Yeah. 255.0. Okay. star times 5.0. Calculate the voltage value. Right, that's what that line does. All right. So we're now going to print. Brackets on. Quotes. Half quotes. I don't know. ADC value. Colons. Percent. And it's D. And that's a comma. Voltage. Colons. Percent. D. Oh, sorry. Percent. Dot. 2F. Quotes. Percent. Value. Voltage. Brackets off. Brackets off. Let me just check that again. ADC space value. Colons. Percent. D. Comma. Voltage. Colons. Percent. Dot. 2F. Quotes. Percent. Value. Voltage. Cool. Looks right to me. Time dot sleep. Time dot sleep 0.1, yeah? Right. Okay. I'm hoping this is okay. But we're here to learn. We don't need the clean up, do we? We're not using any GPIO pins. So the thing we do need though is a DC dot close. Open and close brackets. Right. Fingers crossed. Fingers crossed. Fingers crossed. File save. Save that. Let's do a couple of keyboard interrupts and let's run the code. Okay, line 4. Line 4. Error name ADC. Spelling mistake. Looks like. Device. Device. Let's save that. And code. Here we go. Now, let me just turn the knob, see it changing. Backwards and forwards. I'll just go over to that view so you can see what's happening. So I'm turning this knob here. And it's changing. All right, let me just change back. 104-ish. Turn it to the left. It goes up to 353. A bit further. 998. That's right over to the left. Go over to the right and it's on 0. So we go from 0 to 5. Yeah? 0 to 5. And that's in the code here. The voltage value. Yeah? Well, there you go. It works. It works. I'm happy with that. See it going up and down. Yeah, I know about that line of code, the else and the print. You'll have to pause the video. You'll have to write that down, because if I was to do it in front of you, it will take ages. All right. So, hope you enjoyed that video. Please don't forget to give us a thumbs up, subscribe and comment. And I'll see you in the next video. Thanks. Bye-bye.